All right, let's take a look at the interval of convergence for this power series. Summation n equals 0 to infinity, 5n, 5 to the n times x plus 1 to the n. So as always, we will use the ratio test to determine the interval of convergence for this power series. So we're going to figure out the limit as n goes to infinity of this fraction. The denominator will be the nth term. And then the numerator, I'll have the same thing, except everywhere I see an n, I'll replace by n plus 1. Okay, so we'll make a simplification. So we have 5 to the n plus 1 over 5 to the n is simply 5. Also, x plus 1 to the n plus 1 over x plus 1 to the n would just simply be x plus 1. And the goal is we need that to be less than 1. Okay, so that means we need to have 5x plus 5 in absolute value needs to be less than 1. Written another way, negative 1 is less than 5x plus 5, less than 1. Subtract 5, negative 6 is less than 5x, less than negative 4. And then dividing by 5, negative 6/5 is less than x, less than negative 4/5. And so this would be the interval of convergence. If I were to write this in interval notation, I get negative 6/5, negative 4/5. And clearly, if I were to write this or to express this in a picture, the interval that goes kind of something like this between negative 6/5 and negative 4/5, something like that. There's another way to look at this, and that is, let's take this equation again here. I can pull a 5 out. 5 times the absolute value of x plus 1 is less than 1, so that the absolute value of x plus 1 is less than 1/5. And this is another way of seeing the exact same thing. This interval is centered on negative 1. So I have x minus negative 1 less than 1/5. This negative 1 tells me the center of this interval. Also, the radius of this interval is 1/5. I go 1/5 up or 1/5 down to get to the two extremes. So the radius of convergence is 1/5, and the interval of convergence is from the interval negative 6/5, negative 4/5 open interval.